All right, Year 12, we're coming to the final one that you need to know now, which is an irreducible quadratic. So if we look in here, an irreducible quadratic, all that means is that there is a quadratic, an irreducible quadratic factor in the denominator. And over here they say it can occur n times. Really, you usually only get it to be a squared power. I think they do a squared and a quarter, and we'll have a look at the example they do. Now, an irreducible quadratic just means that the quadratic in the bottom has no real solutions. It only has complex roots or complex solutions. So, for example, here we've got x squared plus 1. Well, x squared plus 1 only has these two solutions, and they're complex. So how do we go about solving these? Righto. So let's set it up. And I'll do an example one again. And I'm just going to take 2x plus 3 on x squared plus 2 x minus 2. And we're going to try and write that as an irreducible, as a partial fraction. And the way we're going to write it is we're going to write a linear equation up here, ax plus b on the irreducible one, and then we're going to have a c on the other factor, the x minus 2. All right. So if we do that, and we say that those two things can be equal, again, we multiply by the denominator on the left-hand side there, and we get 2x plus 3. Now, this is going to be ax plus b times x minus 2 plus c times x squared plus 2. Now, again, the work solutions go through this and do it a little bit differently. I much prefer to do it like this. I'm just going to let x equal 2. And that's going to make that equal 0. So I'm going to get 2 times 2 plus 3 equals 0 plus c 2 squared plus 2. So I get 7 equals 6c, 7 over 6, 7 over 6 equals c. Now, to find the second part, a and b, we're going to expand. So now I get 2x plus 3, and I get, so if I expand that, I'm going to get ax squared minus 2ax. So I'm just doing this up here, that times that, that times that, that times that, that times that, and I'm going to get two things here. So I'm going to get 2 things here. I'm going to get, so I've got ax squared minus 2ax plus bx minus 2b. And then over here, I'm going to get cx squared plus 2c. And now I'm going to collect all my coefficients and like terms, because I'm going to equate coefficients with this. 2x plus 3. Well, let's grab all the x squareds. Well, I've got an ax squared here and a cx squared there, so I'll grab those two, and I'll write that as a plus c x squared. And they're all my x squareds. Now I'm going to grab all my x's. So there's one here and one here. So I'm going to get b minus 2a x. And then I've just got my constants at the end, which is 2c minus 2b. And now I can equate the coefficients. Well, this is pretty easy. A plus c, there is no x squared on the left-hand side, so that equals 0. And we already know what c is, so we'll just sub that in. So a plus 7 on 6 equals 0. A equals minus 7 on 6. Now we'll do the next one. B minus 2a. Well, that goes with the coefficient over here of the x. Those two are equal. So that gives us b minus 2a equals 2. Now we've got a, so it's going to be b minus 2 times negative 7 on 6 equals 2. That's b plus 14 on 6 equals 2. B equals 2 minus 14 on 6. B equals negative a third. Now, we've already got C. Remember, we got it back here when we substituted x equals 2. So now we know what we've got. Therefore, 2x plus 3 over x squared plus 2x minus 2 equals minus 7 on 6x, because that's what A is, minus a third, because that's what B is. Well, sorry, it should be plus minus a third, but we know that that will just make a minus a third, all over x squared plus 2 plus 7 on 6 on x minus 2. Now remember, the whole point of this is to integrate. So here we go. If I'm going to integrate this, and I can dx, integrate these two bits separately. So what am I going to do? Well, let's just take the first one. I'm going to split that again. I'm going to get minus 7 on 6x over x squared plus 2 dx, and then I'm going to get the minus a third, the integral of, well, I'll take that minus out of the sign, so minus the integral of a third of x squared plus 2 dx, and then I'm just going to take that 7/6 out, plus 7 on 6, the integral of 1 on x minus 2. And already you should see that the last thing is going to integrate very easily, because that's just ln. Now, let's tidy this bit up. Well, let's take that minus 7 on 6 out, and I've got x on x squared plus 2 dx. Now, I've almost got the derivative on top. I need a 2 in there, which means I need to go 2 down here. All right. Now I'm just going to take this a third out of this integration here. I'm going to get 1 on x squared plus 2, and you're going to recognise that from your standard integral sheet. And already over here, plus 7 on 6 ln x minus 2. Okay, we're almost done. Up here, I've got minus 7 on 12 ln x squared plus 2 minus 1/3. Now, the integral of this is tan, inverse tan of the square of x over the square root, and I've got to divide by the square root as well. And then I've got 7 on 6 ln absolute value x minus 2 plus some constant. And that's it. And that's pretty tough. So now I'm going to do question 6a. And you can see 6a down here. And it's just these ones. And you can see in the bottom it's very similar to the one we had before, and it tells us what to do. And you can see that you get these ones here as well. And you can see you're going to get the same thing here. So that's what you need to be able to do. Okay, so I'll do question 6 up here. So here's 6a. And I've got 2 on 1 plus x and 1 plus x squared. And I'm going to write that as a on 1 plus x plus bx plus c on 1 plus x squared. All right. Multiply by the denominator in the left-hand side, and that'll leave me with 2 on this side, and I'll get a 1 plus x squared plus bx plus c 1 plus x. Now the first thing I want to do is I want to try and find a value. So I'm just going to let x equal -1, and that will make this all equal 0, so I'll find a value for a. So 2 equals a 1 plus -1 squared plus 0. 2 equals a 1 plus 1. Well, 2 equals 2a, 1 equals a. Well, that was pretty easy. Now I have to expand it. So here I go. And I'll go over here now. So to expand it, I get 2 equals a plus ax squared plus, and I'm going to get 4 things here. I'm going to get that, and that, and that, and that. So it's going to be bx plus bx squared plus c plus cx. And I'm going to try and tie it all together. So I'm going to get all the x squared. So I've got an a and bx squared. So I'm going to get a plus bx squared. And I've got a b and a cx. So b plus cx. And I've got an a and a c at the back. A plus c. Now, I'm just going to equate the coefficients. And I know that there's no x squared there. So a plus b equals 0, but over here I know that a is 1, so 1 plus b equals 0, so b equals -1, and over here I know that b plus c, well there's no coefficients of the x squared, so b plus c must equal 0, and b is -1 plus c equals 0, so c equals 1. And if you really wanted to check, you just go, well, a is 1 and c is 1. 1 plus 1 is 2, and that corresponds with that over there. So great. Now, therefore, we want to integrate. I might be able to fit this in here. So the integral, so this is b, 6b, the integral of all this, 2 on 1 plus x squared 1 plus x dx equals, well, it was a on 1 plus x, so the integral of 1 on 1 plus x, that's going to be good, plus minus x plus 1 on 1 plus x squared dx. Okay, so here we go. Well, we'll just separate out that first one. So we've got 1 on 1 plus x dx. Now, I'm going to take that 1 on 1 plus x squared, 1 on 1 plus x squared dx. I'm going to separate that out. So I just took the 1 and this out. And then I'm going to take minus the integral of x on 1 plus x squared dx. Now, I'm going to do this now. That last one, I almost have the derivative on top, so if I put a 2 in there and I take a 2 out the front, I should be right. So here we go. The first one, very easy. ln 1 plus x plus 1 plus, that's just inverse tan x. And here I've got minus half ln 1 plus x squared plus c. And that's it. I'll just double check the answers to 6C, 6B, which I've got on my other computer, so I'm just going there now. And yes, they've got it in a slightly different order. They've got the tan x at the back, or the inverse tan x, but it's right otherwise. So, a lot of work to be done. Good luck.